Black holes are no doubt one of the strongest places in the universe, and to fully appreciate why you just can't swan dive or pilot a spaceship into a black hole, you first need to understand the basic properties of these gravitational gullions. Simply put, a black hole is a place where the gravity is so strong that no light or anything else for that matter can escape. A black hole, is a place where the force of gravity is so powerful that you would be traveling at a speed faster than the speed of light to escape its will, which would be like traveling in your past. I mean, time travel. Since nothing in the universe is faster than the speed of light, therefore nothing that falls in a black hole can ever escape. And the border at which the gravity becomes strong enough to create that phenomena is known as the event horizon, which marks the outer boundary of the black holes. Black holes are aptly known because they usually don't reflect light or emit light. They're only visible when they're feeding on stars or gas clouds that stray close to the boundary called the event horizon. And beyond that event horizon lies a truly minuscule point called a point of singularity, where gravity is so intense that it infinitely curves space and time itself, as predicted by the Einstein's general theory of relativity. And this is where the laws of physics, as we know them, break down, meaning all the theories about what lies beyond are just speculations. Closer to the center, gravity is even stronger. If you were caught by the pull of a black hole, you would be sent into a free fall towards the center. The pulling force would increase as you moved toward the center, creating what's called a tidal force on your body. And that is to say, the gravity acting on your head would be much stronger than the gravity acting on your toes, assuming you were falling head first. That would make your head accelerate faster than your toes, and the difference would stretch your body until it snapped apart, first at its weakest point and then disintegrating rapidly as the tidal forces become stronger than the chemical bonds holding your body together. You'd be reduced to a bunch of disconnected atoms, and these atoms would be stretched into a line and would continue in a processional march, as if you had been extruded through space like a toothpaste being squeezed through a tube. No one knows for certain what happens to these atoms when they reach the center, or the point of singularity of a black hole. Black holes, they come in different varieties and can be modeled with different levels of complexity, like whether or not they spin or they have an electrical charge. So if you jumped into one, your exact fate, would depend upon the sort of black hole you choose. And if I take it to a simplest level, there are three kinds of black holes basically: stellar mass black holes, supermassive black holes, intermediate mass black holes. Smaller black holes actually have a more dramatic gravitational gradient than supermassive ones. In other words, you only have to fall a very short distance to experience an extremely noticeable difference in gravity. The more matter and people the black hole gobbled up, the bigger it would get, and that could have the effect of making it less spectacularly deadly. As a black hole increases in size, the differences in gravitational forces inside them become less dramatic. If you fell into a truly gigantic black hole, the rate of change and resulting tidal force might not be enough to rip your body apart until after you did cross the event horizon. If you fell into a large enough black hole, your last moments would be a little bit like being on the inside of a distorted one-way mirror, and no one outside would be able to see you, but you did have a view of them. Meanwhile, the gravitational pull would bend the light weirdly and distort your last moments of vision. Sorry to all those science fiction fans, you can't actually survive a trip through a black hole, and if you try to take a plunge into one, like Matthew McConaughey in the movie Interstellar, you would be ripped apart long before you could find out what's on the other side.